is interested in doing some SFT work, as Jing just said. Now, today he's going to talk about how to use these frameworks to study phase perception. So let's welcome Mario Fific.
Thank you very much. I really appreciate you inviting all us here, and I have to say that I really admire Cheng Tai, for his achievement in getting such an important grant. I was very surprised when he invited me to collaborate in a domain of phase perception. That would perhaps explain the way we first met. I met him several years ago at one international conference. I didn't know about Cheng Tai before. And I was going through the poster section, and there's so many posters there, and I was jumping this poster to that poster. And then I saw the poster that actually I can completely understand. And I turned to Cheng Tai and I was like having my eyes open like this. And he politely asked me, as it is practice, would you like me to guide you to the poster? And I said, no, I will guide you to the poster. I'll explain what's in the poster. So I just guide him, look, you have this, you find that, and then this is because I completely understand what he was doing, and this is because we share each interest in using the same tools. So I did 2 talks, and the first talk would be about the importance of the mental architecture. So the main goal will be about that. But I have another one talk tomorrow, and I'm hoping that talk will provide more tutorials, so to say, how maybe to use this material. So some things will not be spoken today. Well, we'll have to wait maybe till tomorrow. So I'll just carefully keep certain things. This particular research was done with the Jim Talent here, and he was my graduate student mentor, and we collaborate and we start to build up, those new approaches to testing mental processes. Among them, we really focused on the domain of phase perception. The name of this technology that we worked on is the systems here Factorial technology. Okay. So let me set up goals for this talk. First, we learned something about the procedural operational definition of holistic processing. Procedural operational definition, how we define holistic processes. So also have in mind that when I say holistic processing, this is the same, I was pretty much have about the configural processing here, so I would not make a big difference about it as this. There is a kind of a flexibility between these two concepts, well, we can maybe start to differentiate, but it's not going to be the topic of this research. And the second goal is what is actually mental architecture, and what do we learn, by understanding mental architecture and using mental architecture in the phase perception. And 3, why should we be using them, right? Well, what do we benefit from that? So these are the 3 goals. We are trying to achieve them. Here's a typical prototypical situation in which holistic phase perception fails. So we have a little Red Riding Hood here, and she's not really able to holistically recognize that she's talking to a wolf, not her grandmother. She's paying attention to feature by feature. What about your eyes? What about your ears? What about your mouth, right? But if she was able to holistically see, she would probably see that this is not my grandma, but bad wolf. So this introduces us to the idea of a holistic hypothesis. In general, you can say that the objects are perceived as a whole entity, not as a set of independent features. Hidden to that one is analytic or feature-based perception. And so in contrast to the previous one, we here analyze, we're able to attend the features. This is a general definition of the holistic versus analytic process. And throughout the history, scientists in this area have been collecting many ways how to identify the presence of holism. So if we go here to some of these concepts like the Gestalt laws, pop artifacts, particle paradigm, Garner's asks, superiority effects, different capture illusion, grotesque faces, face inversion, unitization, scramble faces versus normal, narrow responses, how to narrow context effects, Something that is closer to our interest, that Jim already mentioned about is a supercapacity index, and this one is the product from our kitchen, which is called co-activation signature too. So we see we have many of these different ways we can try to identify holism. The question is whether they are really good indicators of holistic processes or not. And we also pay special attention to this particle paradigm that has been used by several researchers before. So, seeing that, I'll try to introduce you about the procedural operational definition of holistic processing of phases. So let's see what's that. What do I mean by that? So one way to define holistic processes is to maybe use something that is called part-of-whole paradigm. So in this task, carried by Tanaka Senko 97, you learn Joe's face, yes, and then you have to, in the task, to be able to recognize Joe's, let's say, nose in his old configuration, this is old face, or the nose in isolation, or nose in a new configuration. So that's the part-of-whole. So they try to investigate whether you can access the features selectively and disregard what happens with the background or the absence of the background. So one way to approach the holism is to try to find this failure of selective attention. If you cannot access selectively to independent features, then probably faces are processed more holistically, not as a parts. And here are the results. We can see in this experiment when you had tried to either attend the eyes, nose, and mouth of Joe, we see that recognition accuracy fails when compared to when this feature is embedded in the old learned configuration when this is new configuration and isolated parts. And it happens with all these features. So this is the failure of selective attention to a certain facial feature. And so how does it work? I just try to come up with maybe a more visual way to give you the idea. Let's say this is a cognitive representation. This is what you have in mind. This is holistic now representation. And this is what's going to be displayed here. So let's say that you are shown this old face, and then you have to pay attention to that feature. Recognition, in this case, gives you relatively accurate response. Right? So this is kind of old configuration situation. If you have to pay, if you're presented only with the isolated feature, and this is what you have in mind, then what happens, after some process, you achieve certain accuracy, but now it's lower, right? Because you're just missing this context, so you're running into some errors from time to time. And then if you presented the same feature, but with a new background, so this is new configuration, then it should be also difficult, to make this distinction. So this difference here between accuracy detection is called failure of selective attention. So we agree about what is failure of selective attention. Part of the whole paradigm, failure of selective attention. If you're working in a maybe analytic brain, and in analytic brain, you'll be maybe storing these representations like the feature-like representations. They're active, and then when you show the whole figure, the entire old configuration, you have some accuracy, right? If you show the isolation feature, like in this one case, categorization is accurate, and then in new configuration, does not matter. Pretty much, the idea here is if you're using analytic processing, then accuracy should not be affected much with the changing different contexts. So that's the idea. Let's call this roughly strong analytic hypothesis here. So the idea, if you find failure of selective attention, that will indicate holistic, and if you don't find this effect, it will indicate analytic processes. And now we're approached to what is an operational definition of holistic perception. We say the holism is the same thing as a failure to selectively attend to facial feature, regardless of the face context. Okay, so that is procedural operation because we define holism in terms of the way we conduct the study. Of course, this failure of select convention is very important to understand certain processes in the phase perception, but we say it's limited because it ignores important part of our processing machinery, such as we don't know anything what happens with the cognitive processes during that phenomenon. What do I mean by processes? We think that goes in a large area of what is called information processing systems. So what do you mean by this? Well, actually, I mean we know nothing about the mental architectures the way the processes are organized. Mental processes are organized underlying phase perception. So this is the missing part. And what are actually the mental architectures? Maybe this is a second goal. Now we try to move to the mental architecture. Here, probably the best way to explain what I mean by mental architecture is to explain the properties of fundamental properties of cognitive processes, and we have three categories at least here. First one, specifying processing order. So we have a set of processes, maybe like feature detectors. Maybe they could organize in serial or parallel fashion. Here's another thing, they could organize maybe in coactive fashion. I'll talk more about this. But this is the way processes are sorted. Second thing, we have to define stopping rule, right? When is enough for information accumulation, and when do you have to make a decision? If you can make a decision based only on processing one feature, then it's called terminated. If you have to process everything there, it's called exhaustive. So processing order, stopping rules. We have interdependency between features. So whether the features are dependent or independent. Jim mentioned about how big this problem is. What does it mean dependency? But here, largely we think this is whether the processes can occur without knowing anything about each other. This you can maybe if you have dependency violated, maybe the processes could be facilitatory or inhibitory. If they inhibit each other, maybe facilitate each other. And finally, we have something about the capacity. Capacity will be dealt, here in the other presentations, not this one. So we'll just quickly skip over this one. So here, I think this is a critical graph. We have different catalog of mental architectures. That is the missing part I was telling. And mental architectures here are, for example, this is a serial self-terminating system on processing two facial features. So you process eyes and lips. And this one in particular, you process first eyes, but you can stop after processing eyes and go to the decision stage and only make the decision based on eyes. And that is what we have OR gate. It could be serial exhaustive architecture, so we have to process both features and eyes and lips, and then we make a decision. That's why we have AND gate here. Processing is strictly sequential, right? Like here too. Parallel self-terminating, we're processing parallel features. And first one that finishes will trigger the response. So we don't actually have to wait for the eyes. We just need the lips to trigger the response. This is OR gate. This is also called horse race model, right? And we have response. And here we have parallel exhaustive. We have to parallel process two features, but we have to process them both. This is AND gate here. E is the most interesting case for the particular